Okay, so moving on to the second formula that you need to put into your toolbox. It's called the midpoint formula, and basically what we are going to be using it for is exactly that, finding the middle of a line segment. The formula that you need to learn is for the x-coordinate of the middle point, you're going to have to take the x-coordinate at the first point, add it to the x-coordinate at the second, and find the average of that, which is dividing by 2. And then we're doing exactly the same process for the y-coordinate. Add the two y-coordinates and then divide by 2. Again, that finds the average. So our writing tells us that the midpoint formula is used to calculate the midpoint of a line segment, and we are going to apply it in this particular example below. So what we have is a line segment. The coordinates at A are given to me as 2, 3, and the coordinates at B are given to me as 5, 7. And the question is actually wanting us to find out what are these coordinates here at the middle, and I'm going to just call them for the moment x, y. So how we set up our work is as follows. We say our midpoint, all right, and our formula is, in our particular case, it's A's and B's. So I'm going to take the x at A and I'm going to add the x at B, and then I'm going to divide that by 2. And similarly, I'm going to take the y at A and the y at B and divide that by 2. So all I need to be now is very cautious as I plug the values in. So the x at A is a 2, the x at B is a 5, and I'm going to divide that by 2, and then the y at A is a 3, and the y at B is a 7, and I'm going to divide that by 2. And failing anything, we're going to get this perfectly correct. We just need to do the arithmetic. 5 and 2 is 7 over 2. 7 over 2 is the same as 3.5. 7 and 3 is 10 over 2 is 5. So we know that the midpoint is 3.5, 5. So M, in this particular case, is 3.5 and 5. Now, I told you that analytical is a very visual topic. So what I want to show you here is actually, if we had used our eye for this, we can actually confirm what we've got by using the formula. Okay, so if I was moving from A across to in line with B, then this coordinate for C, the x-coordinate at C, would also be a 5. If I'd moved from A across to in line with B, C would be a 5. Notice that if I was moving from 7 up at B down to in line with A, the C coordinate at Y here would be a 3. Okay, so can you see that visually, if I've moved from A across to C, I have actually moved 3 units in total. Let's make that clear. 3 units. All right? And if I've moved from C up to B, I've actually moved 4 units up in total. So it makes sense that if I were now going to work out the coordinates at M, can you see that if that total is 3, then it makes sense that this piece here has to equal this piece here. So this would have to be 1.5, and this would have to be 1.5 across. So if I've gone from 2 and I add 1.5 to 2, that would place my M value as being 3.5. And likewise, if I was moving up, can you see that halfway here, this would have to have moved up 2 of the units. This would be a further 2 of the units. So visually, 3 move up 2, then move up another 2 would get me to 5. So visually, I can check that my answer was halfway between 2 and 5, which is 3.5, and halfway between 3 and 7, which is at 5. Just a natty way of checking whether you've got your answer correct. Okay, not too difficult, but, you know, as teachers we do come along and we do try and shake things up a bit, so this is how we can change our approach in the question. So they give us a line segment AB. Now notice that they're telling us that M is the midpoint of the line segment, and what they want us to do this time is they want us to actually find one of the end points. All right, compare it to the one before. The one before, they actually gave you the end point. The end point asked you to find the middle. So here they just change things a bit and they give us the middle, all right, and they ask us to find the end point. All right, let's have a look and see if we can do this visually first of all. So what would happen if I measured the change across there and up there? All right, can you see that across from 1 to 4, I would be moving 3 units that way. And from 3 up to 5, I would be moving 2 units. Now, because it's a middle point, we would actually be expecting the movement from A to M to be equivalent. All right, so I would be expecting this to also have moved across 3 units, and this to also have moved up 2 units. All right, so let's see if we can do this by just inspecting it. All right, this went from 1 up to 4, a change of 3. So what number would we have to move from and change 3 to get to 1? All right, can you see what I'm doing? So of course our answer there is going to be -2. So -2 changed by 3 would get me to 1. What number would I have to have started down at, moved up to get to 3? Yes, I think you can see that. It's a 1. So this is if I did the sum by inspection or just by gut feel. And so much of analytical is by gut feel. All right, but the question most likely is going to say use an appropriate formula. So we can't get away from it. So again, we know that our midpoint formula, all right, given to us is x at the one plus x at the other over 2, and y at the one plus y at the other over 2. All right, but now remember that this time we know our midpoint, and our midpoint is given to us as 1, 3. So let's have a look at how we're going to work this out. We're going to capture just one of these at a time, or work with one of these at a time. So I'm going to say x at A plus x at B over 2 has come out to be the answer of 1. Right, now if you recall, x at A is a mystery, but x at B is a 4. And they tell us that if we divide that by 2, we get an answer of 1. So can you see that they've just shaken things up a bit, okay? So we're not finding the midpoint. We know the midpoint is 1. We need to find the x at A value, which means that I'm going to have to solve this easy equation. So I'm going to get x at A plus 4. And notice that what I'm going to do is I'm going to times that by 2 to cancel it, and times this side by 2. So I'm going to get x at A plus 4 is 2. So the x at A is going to be a 2 minus 4, which is -2. So we've worked out the x value at point A. So similarly, we're going to do exactly the same thing on the other side, and we're going to work out the y value at A. So just popping in the formula, and they told us that the y value of the middle point is 3. All right, so that's where you just have to be careful. We have to inject the y value into being the subject or the focus of our equation. So the y at A is our mystery value. The y at B is a 5. Divided by 2 must come to 3. So with similar methods, we're going to multiply both sides by 2. So our right-hand side becomes 6. And so our y value at A becomes 6 minus 5, or 1. So having done all of the algebra solution, I know that A, the endpoint, has coordinates -2 and 1. Now, of course, we could just go back and check it, and by inspection, by just moving around on the plane, we had got our A value to be exactly the same, -2 and 1. So I know you most probably thinking, can you do it purely by inspection? Well, it depends on how they've asked the question. If the question's out of 2 marks, then absolutely. But if they say by using an appropriate formula, then you are going to have to show the mechanics of how you solve those 2 linear equations. So don't fall short if you don't do it by inspection if they say use a formula, because then you'll lose the method marks. Okay, rather use it as a checking mechanism. Right, so we go on to the third and the final formula which you need in grade 10 analytical geometry, and it is the gradient formula. And it says as follows. The next formula that we're going to have to look at is the gradient formula. You will probably remember this formula from grade 9. Now, I'm sure that some of you look back with some kind of horror because this was linked to drawing straight lines, which so many of you found so difficult in grade 9. However, I promise you, it does get easier. These concepts are now in your head, and so I'm hoping that you're just going to look at this and say, well, why did I battle initially? I really don't know. So gradient is y2 minus y1 over x2 minus x1. Of course, it could also be y1 minus y2 over x1 minus x2. It could also be y at A minus y at B over x at A minus x at B. So can you see that this formula is just a generalized formula? It tells you that you must take one of the y values and subtract the other, and then the same point. You must just use the same point as the initial starting point. So then the x value at the same point minus the x value at the same point. So y1, x1, y2, x2, ya, xa, yb, xb. So these formulas are completely interchangeable because your points you could actually random name. But so many of you also learnt that gradient was actually rise over run. And so let's just make sure that rise is the change in the y values, and run, so change in y, and run is the change in the x value. So it's how much is the line moving up or down compared to how much is the line moving across to the left or right. And that gives you your steepness or your slope or your gradient of your line. So this beautiful picture here shows us very clearly what we should know from last year, is that a line with a positive gradient runs uphill from left to right. So this is when our gradient is any number greater than 0. So for example, if I tell you that my gradient is a half, or I tell you that my gradient is 7 over 3, as long as this fraction is positive. So this means for every 1 that I go up, I have to move 2 across. For every 7 that I go up, I have to move 3 across. All right? So move up 1, 2 across. Move up 7, 3 across. But by comparison, if your slope is going downhill, in other words, your gradient is negative, our gradient being any negative number, and of course, negative can present itself in 3 different ways. It could be written negative a half, or it could be written as negative 1 over 2, or it could be written as 1 over negative 2. Now please have a look at that and see that those 3 gradients are all equivalent. All right, we know that when we write a negative fraction, the negative could be presenting itself in the front, or together with the numerator, or together with the denominator. But what this would mean is that if I went 1 up, I would go 2 across. And can you see that when I'm running, I'm going to the negative side? All right? This would mean I'm going 1 down and 2 across. And this would also mean 1 up and -2. In other words, 1 up positively, but 2 to the negative direction. So I'm sure you remember that from last year. Let's have a look at how we would apply it. And I am now working with you on page 155, down the bottom, just underneath the pictures of the motor cars. And it says that we want to find the gradient of this line. Okay. Now, how do we set it out? Well, first of all, if we use M, we're going to maybe be confused with the letter that we use for midpoint. So I always make sure that if I'm using midpoint, I actually write out the word. Okay, so midpoint of AB. But conventionally, we actually, if we use the letter M and we write MAB, we take this to mean the gradient of AB. All right? So, what did we say about the gradient formula? We said that it must be the change in the y values. So I'm going to write it as YB minus YA, and then it must be over the change in the x values, XB minus XA. And of course, just to repeat, you could have done it the other way around, just keeping your values in line. So YB, XB, YA, XA, YA, XA, YB, XB. Right, so let's plug in our values. These values are 3 and 4. So this is going to say 4, subtract the y value at A, so again, just be careful. And then the x value at B is a 3, minus the x value at A, which is a -1. And if we plug that in, we now get a value of 6/4. We would not leave it like that. We would take it down to its simpler form, which is 3/2. Just for clarity, let's make sure that if we'd done it the other way around, to prove to you that we get the same answer, we would get -2, subtract the y value at B, which is a 4, and then we would get -1, subtract the x value at B, which is a 3, which gives us -6 over -4. And are these equivalent? Well, yes, because when we divide a minus into a minus, we get a plus, and divide each of them by 2. So our gradient is 3/2. Just a hint, please, if you've got a picture, make sure that your answer actually confirms this is a gradient of 3 up, 2 across. It's a positive gradient, and so my line should be looking as if it's going up the hill. So visualize the car going up for a positive gradient and down for a negative gradient.